Now I'm going to do the first crashing problem. Here we have a network, and we're interested in reducing the duration of this project, and we want to do it as cheaply as possible. So we're going to use the least cost method of crashing or reducing the duration of a project. So the first thing we need to do is figure out how long it would take normally and what the total direct cost would be. So we have the durations in the boxes. We're not interested in slack and forward and backward pass, so we're keeping things simple in terms of a single cell in terms of duration. And we look here, 1, 3, 3, and 3. That's 10. 1, 4, and 4, and 3. That is 12. So this is the critical path. And the normal time is 12. We total up the normal costs here, and that comes to 1,000. So now we're interested in seeing how much it would cost to reduce this network from 12 to 11. So here we want to look at the cost associated with crashing activities. And we have to look at these two columns. The first column, maximum crash time, tells us how many days, let's say, that we can take off for a given activity. In the second column, the crash cost, or the slope, is how much it costs us to crash that activity each day. So for activity A, we can't take any time off the normal time of 1, which makes sense, and doesn't cost anything. But activity B could be reduced all the way to 1 day in terms of time, and for each day would be $100, let's say. So if we're going to take it off from 3 to 2 would be 100, and from 3 all the way to 1 day it would be $200. Activity CD, we can take off 1 day, cost of 50 and 60. E is 2 days, $70 each, and 1 day for activity F at $90. So we look at the critical activities and pick the one with the cheapest crash cost. And we look at C, the cost is 50. We look at E, the cost is 70. And we look at F, the cost is 90. And we choose the cheaper cost, which would be C. So for $50 additional, we can go from 12 to 11 days. So let me move this up a little bit. Go ahead and record those changes. Put a 3 in here for C. We've crashed it the 1 day we can, so we put an X there. 3 up here. None of the other activities have changed. Put in 3. We indicate that we crashed activity C at a cost of 50. 50 plus the 1,000 gives us a total direct cost of $1,050. Now we want to see what it would take to get from 11 to 10. And here again we look and identify the critical path. 1, 3, 3, and 3 is 10. This is 11. This is still the critical path. Now 2 of our options aren't available, so we're looking at E or F. E costs 70. F costs 90. Choose the cheaper one, which happens to be E in this case. So I've gone ahead and recorded the change in E, taking it from 4 to 3, recorded it over here under activities changed, and added that to the 1050 to get 1,120 for the direct total cost for doing the project in 10 days. Now let's see what it would take to get it to 9. We check our critical paths. 1, 3, 3, 3 is 10. 1, 3, 3, 3 is 10. So now we've got 2 critical paths. And this is to be expected as we begin to compress that network and reduce slack as a result of that. So now we have to influence both paths. And we have 2 options available to us. We can crash E in some combination of B or D. E costs us 70. B costs us a big 100. D costs us 60. So the cheapest option there would be D and E, which would be 130. Or we could crash F, which is on both paths, and even though it costs 90,000, it would be cheaper than crashing two of the other activities. So we would choose F in this case. So we'll do that and show you the next sheet in a second. So I've gone ahead and recorded the change in F. The 90,000 has been added to the previous total to give us a total direct cost of 1,210 to do the project in 9 days. Notice I put an X next to in the F box because we used up the 1 day we could for that particular activity. Now let's see what it takes to get from 9 to 8. We know from our previous work that we have two critical paths. We killed two birds with one stone with F, but now we're going to have to reduce two activities in order to go from 9 to 8. We know we have to do E because that's the only way we can influence this path, given that the other three have reached their crash points. Now we have to choose between B or D, and B we know costs 100 and D costs 60. So we're going to have to add that with the cost of E, 60 and 70, to get us from 9 to 8. So I've gone ahead and recorded the changes in both D and E, put X's next to them because they reached their maximum crash time, total up the two costs. We got a new total of 1,340 to do the project in 8 days. Now let's see what we can do in terms of getting to 7. Check here. Still got our two critical paths. But notice that this path, A, C, E, and F, each one of these activities can't be crashed any further. They all have X's. And therefore, even though we could crash B, nothing would be gained from that in terms of shortening the duration of the project. Because even if B was done in 2 days, and therefore D was done at the end of the 5th day, F would still have to wait 6 days for E to be done. So now we've reached what's called the crash point for the network. The point where, given the information that we have, the nature of the network, what was possible in terms of crashing, we can reduce this network no further than 8 days. And again, the key point here is all the critical paths have to be able to be changed in order to shorten that duration. And in this case, one of the paths is X'd out. As soon as you see that, you know you've reached the crash point for the network.